Hey, Math for College. Today we're going to look at transformations. You've seen this before. We're going to start by making a t-chart, plugging in some x, y values, and we're going to start with f of x is equal to x. So our goal today is to be able to look at these parent functions and their transformations. So these they're called parent functions because they kind of make up all the other functions. Kind of like they have children and they look, similar but a little bit different. Just notice that f of x, that's notation for function. It'll be like y is equal to x. Okay, y is equal to x. So I'm going to use these values. If y is equal to x, then if x is negative 2, that means y would have to be negative 2. And if x was negative 1, then y would be negative 1. And 0 and 1 and 2 and so on and so forth. If you plot these coordinates, negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2. Notice the line you get. So if you have x to the first power, you're going to get a line. What happens when you have x to the second power? Let's look at negative 2, negative 1, 0, 1, and 2. And this is y is equal to x squared, or f of x is x squared. If you plug in negative 2 for x, you square it, you get 4 for y. Plug in negative 1 for x, you square it, you get 1 for y. Plug in 0 and square it, you get 0. Plug in 1, you get 1, 2, you get 4. Notice how all these values are positive. Negative 2, positive 4. Negative 1, positive 1. 0, 0. 1, 1. And 2, 4. Notice the shape you get. We've already talked about it. It's a parabola. So if you get x squared, it's a parabola. Now we're going to cube it. Means multiply it by itself. Negative 2 times negative 2 is 4. Times negative 2 is negative 8. Negative 1 times negative 1 is 1. Times negative 1 again is negative 1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. And 2 times 2 times 2 is 8. So negative 2, negative 8 is going to be about down here. Negative 1, negative 1. 0, 0. 1, 1. 2, 8. Function is going to look kind of like that. We call that a cubic, third degree. We're going to do this one first. Y is equal to absolute value of x. So negative 2, negative 1, 0, 1, and 2. The absolute value of negative 2 is 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So if I plot these, I get a V shape. So it's very similar to the parabola, only the parabola is curved. This absolute value function has a V shape to it. For x, I'm not going to plug in negative 2 because you can't take the square root of a negative. I'm not going to plug in negative 1 because, again, you can't take the square root of negative. But you can take the square root of 0. I'm going to use 1, 4, and 9. Because the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So if I plot those 0, 0, 1, 1, 4, 2, and 9, 3. You can see you get that kind of shape. That's a square root function. The last one we talked about is f of x is equal to c, or a constant. For example, let's say y is equal to 3. Negative 2, negative 1, 0, 1, and 2. This is the constant function. And this is that the y value is always 3. So suppose x is negative 2. What is y? Notice there's nowhere you can plug it into. It just tells you y is always 3. So it doesn't matter what x is. I just always put 3 for y. And so that's going to create negative 2, positive 3, negative 1, 3, 0, 3, 1, 3, 2, 3. It's going to be a line that's horizontal. The slope is 0. So that'll be a constant function. So now that you have these functions, these are the 6 functions you want to keep in mind: the constant function, the linear function, the quadratic and the cubic, the square root function, and the absolute value function. You want those shapes in your brain. And what we're going to do now is we are going to look at Desmos to see how these graphs change as we type them in. And so I'm going to go ahead and grab Desmos and move back to my computer here. Hold on. Okay, Desmos is a great graphing calculator, and what I'm going to do is I'm going to go in here and I'm going to type in first x squared. So y is equal to x, and we're going to square that guy. And notice that we get the parabola just like you thought you would. And I'm going to hit enter, and I'm going to look at the next one and see what happens. I'm now going to look at this guy, which is y is equal to x squared plus 4. So y equals x squared plus 4. And let's see what happens. Oh, it looks like the same graph. It's just shifted up 4 units. Up 4 units. So to go back here, I'm going to just do up 4. That's what happens there. The next one, we're going to put a negative in front of it and see what happens. So let me take that same function, and I'm just going to put a negative in front of it. Ooh, the negative flips it upside down. So I'm going to go ahead and go back to this function here, and I'm going to have it upside down, and it's up 4 yet. So it's up 4 and it's upside down. Let's look what happens if we do this. We're gonna change it now. We're gonna do an x minus 3 on the inside of that piece. Let's go back here. We'll do parentheses x minus 3 parentheses, and then we square it. And it looks like it moved it actually to the right 3. Isn't that interesting? When you did a minus 3 on the inside, like inside those parentheses, instead of moving it left 3, it moved it right 3. So I wonder if you could guess what's going to happen here. We have that plus 2 on the inside there. If you want to try to make a guess of what's going to happen before we plop it on up here. But sure enough, it moves it left 2. So instead of 2 to the right, goes 2 to the left. So it looks like when it's on the inside like that, it's kind of opposite of what you thought it was going to be. So left 2. So let's see if we can put it all together and make a prediction here. The plus 5, is that going to move it right 5 or left 5? And if you said left 5, you're correct. And then this plus 1 out here, that's going to move it up 1 unit. And then this negative, that's going to flip it upside down. So we should see left 5, up 1, and upside down. Let's try plugging it in here. And so we've got a negative on the outside, got a plus 5 on the inside, and then a plus 1 on the outside. And sure enough, there's my graph. You can see it's shifted to the right 5, up 1, and it's upside down. It's nice use of Desmos right there. Okay, I'm back up at front of the board. Now we can kind of look at the rest of our notes and see what's happening here. If you saw the negative on the outside, hopefully you saw that makes a vertical flip. Now, this isn't all of the transformations we can do with functions. That's just the most important piece. And if you saw this k on the outside, if it's plus k, it moves it up. If it's minus k, it moves it down. And then this h thing on the inside, if it's minus h, it moves it to the right, but if it's plus h, it moves it to the left. And so those are the type of transformations we're going to look at. So let's try these 6 here. It says at the side of the graph, list the parent function and the transformations. So y equals x is going to be the parent function. So this is what the original function looks like. Notice how this minus 3 is on the outside. If it's on the outside, it affects it vertically. So it's going to move it down 3 units. So I'm going to take this graph and move it down 3, and that's my new one. For the next one, the parent function is y is equal to x squared, or this parabola shape that you got going on right there. Notice the plus 4 is on the inside, so that's going to affect it horizontally. It's going to move it left 4. So that's my graph. If it's on the inside, horizontal. Outside, vertical. Here we have y is equal to the absolute value of x. That's my parent function. And we are going to do minus 3. And minus 3 is on the outside, so it's going to move it down 3. Y is equal to the square root of x. That is my parent function. We have 2 transformations here. The plus 3 is on the outside. That's going to be up 3. And then this minus 1 is on the inside. It's going to be right 1. Again, opposite of what you think. So right 1 and up 3. There I have it. There it goes. For this next one, we have y equals x cubed. That's our parent function. So what we are going to do is we are going to move it down 3 and move it to the left 2. So left 2 and down 3, so it's going to move that spot right there. And for this last one, we have y is equal to x squared is our parent function. We have 3 transformations here. The minus 5 on the inside moves it to the right 5. The negative in front is going to make a vertical flip. It's going to flip down. And the plus 2 is going to move it 2 units up. So right 5 and up 2 and flipped upside down. And there's our shape. And you can check all of those by using Desmos, which is a really nice option. Okay, folks, hopefully that went well. We'll see you in a Google Meet. We'll try it out.